Hello everyone, and I'm here today to talk to you about how is energy transferred or stored. Alright, and you already saw the beginning of the video, if you look really closely. So this is called a Newton's cradle. Alright, so obviously you pull back the one ball on the one side, you'll let it go, and it will keep going back and forth, hitting into the next ball, and the energy will transfer back and forth. Alright, so a really neat device. I'll actually demonstrate it in another video because there's really cool things you could do with it, and I actually have one here in the classroom. Alright, so let's talk about the storing of energy and the way it works. So there are two types of energy that we know of. Potential, which is stored energy, and kinetic energy, which is energy in motion. So in the last video, when we talked about types of energy, they kind of fall under these two categories. So basically, two kinds of energy that exist. So this is what we were talking about with a roller coaster. Okay, so obviously a roller coaster, you have a huge hill in the beginning. There's a reason why they do that. Okay, so they click you up to that top, and then you get to the top, you're storing energy by putting it at the top of there. Because what's going to pull that car downward is gravity eventually. Okay, and as it comes down, it starts speeding up, and your potential energy is now changing into kinetic energy. All right, and that's why the roller coaster goes so fast, because gravity starts acting on it, and it transfers to the kinetic energy. So potential energy is stored energy when something is not moving. Energy is transferred when something begins to move. All right, and this depends on the position above the Earth's surface, because again, gravity is going to be the driver most of the time for this. There's other examples of potential energy, which I'll show you in a moment, which isn't really gravity induced, but they work in a different way. Okay, so as far as a roller coaster, potential energy being maximized, well, one way you can do it, make the roller coaster huge. All right, so increasing the height. The higher the potential energy, the more potential to fall. You could also add more weight. Okay, in the case of these roller coaster carts, you can have more people in one car. All right, as an example. So sometimes they play around with this formula a little bit, and that's actually how they can play around with how much potential energy is maximized and how much speed comes out of it as a result. Okay, here's the other example. So gravitational potential energy, so a slinky. Okay, so you know you can actually take a slinky, make it walk down the stairs. Really neat to do. So again, tipping it over, again, you're going from potential to kinetic energy as it moves. Elastic potential energy, so rubber band, pulling it back, or a bow and arrow. Again, you're pulling it back and then you're releasing. Okay, when you pull it back, it has potential. Release it, it becomes kinetic. All right, so kinetic energy is energy of motion. The faster the object is moving, the more kinetic energy it has. So an object begins to move, potential energy is going to transform into kinetic energy. Okay, and that's the way kinetic energy is, it works. Okay, so just remember, as one goes up, the other one goes down with kinetic and potential. Okay, so keep that in the back of your mind. So a pendulum, same example. So Newton's cradle, you pull it back. So at position 1, it has a higher potential energy. When it gets down to 3, it has kinetic energy. And then it gets back up to 5 again, it will have potential. All right, and it stops for that split second. So that potential energy, where it stops, is actually where the greatest potential energy is. Okay, so where it's at rest completely. All right, so with the roller coaster at the top of that first hill, where you feel that stop for 1 second and then you go, that's where the greatest potential is. Okay, so potential to kinetic, back to potential, back to kinetic, back to the potential, all right, as it goes back and forth. So again, that's illustrating the same thing. So highest point of swing is greatest potential energy, and then greatest kinetic when it gets down to the bottom of the swing, and then greatest potential once again when it gets back to the top. All right, and that's it for potential and kinetic energy. Thank you guys for tuning in.